What's this? That's a good answer, a repeating decimal. Can you make it a ratio?
Yes, sir.
Can you express that as a ratio of terms? That's the question. If you can, it falls into this group of numbers known as, say it, rational numbers. There's another group of numbers known as irrational. And what root word do they have in common? Ratio or rational. But ratio means that you can express something as a fraction. So with irrational, you're not able to do that. Numbers like the square root of 2. Numbers like pi. There's no end to pi, right? Do we understand that? You can't express it as something over something. A good estimate for pi is 22/7, but it's not exact. All right? The square root of 2. It's about 1.41, but it never repeats. It has all these weird digits, and it never repeats, and it never stops. The math term for stop is terminate. It's a non-terminating, non-repeating decimal, and it's in the group irrational. Now, do you understand why we might include numbers like 0.5 as a rational number? You can express it as 1/2. Does 0.5 stop? Right at the 5, right? There's nothing after it. You could put a bunch of zeros after it, but they're irrelevant. Does 0.25 stop? Can you express it as a ratio? 1/4. What about 0.125? It's 1/8. And if you don't know why or how to express it as 1/8, tell me what decimal place this would be. Tens? Hundreds? Thousandths? Okay, so we can express this decimal as 125 thousandths, and then you could reduce it. Name something that 125 and 1,000 are both divisible by. 5, bigger. 25, let's try 25. How many 25s go into 125? 5. How many 25s go into 1,000? 40. It's like asking how many quarters are in $10. Well, you know one of those rolls of $10 quarters? 40 quarters in there. So it's 40. And can you reduce 5/40? 1/8. So is it easy to see why terminating decimals are known as rational? You can express them as a fraction, all right? But they also say repeating decimals belong in this group, like 0.3 repeating. Why does that belong in this group? What's that as a fraction? You're right, it's 1/3. And since you can express it as a ratio, it's part of the group. Does anybody know what 0.1 repeating is? It is 1/9. So that's why it's part of the group. My goal today is to show you why it's 1/9, or how you can figure out that it's 1/9. All right? And I'll show you right now. One of our problems the other day had 30 plus 3 plus 0.3 plus 0.03, and we realized that that was 33.33333. Remember? So 0.1, can you express it like that for me? Like something plus something plus something plus something? 0.1, start there. Write this down. 0.1 plus 0.01 plus, yep, and so on. Do you understand why that makes 0.11111? Okay, if I added these two together, it would be 0.11. If I included this guy, the 001 would be there. And every one that I added, there'd be another what? 1. All right. So what do you see in red? A sequence or a series? A series. What kind? Geometric or arithmetic? Let's find out. Let's take this divided by this. 0.1. Let's take this divided by this. 0.1. What's this called when we find this ratio and it's in common? It's called the common ratio. What letter? R. So is it geometric? Yes. Is it infinite? How do you know? Dot, dot, dot. Is R smaller than 1? Yes. Does it qualify for yesterday's formula? Let's do it. I like it. 0.1 is our first term. That goes on top. 1 minus 0.1 goes on the bottom because it's 1 minus R. That turns out to be 0.1 over 0.9, which is 1/9. Try it. Enter 1 divided by 9. See what you get. Okay? But we're going backwards. If I asked you what 1/9 was, you would just type it in, and it would say 0.111111. We just figured out a way. If I give you a repeating decimal, how do you figure out the fraction? Okay? Let's see if it works with a more common one. All right? I would like you to take a moment to write down the series that represents 0.333333. Something plus something plus something plus something. There's the series that represents 0.3 repeating in red. So we're going to pause it again. I want you to tell me what U1 is and what R is. So there's our U1 and our R. So go through the three-part checklist. Is it geometric? Is it infinite? Is R smaller than 1? So we can use this formula. So you put the first term over 1 minus R. What's 1 minus 0.1? 0.9. The decimals would get out of time, and you'd have 3/9, which reduces to 1/3, which proves that 0.3 repeating is 1/3. Next, let's try 0.25252525 repeating. Point 252525. Where do you put the bar? You could just, normally you would write it like this, right? So it's 0.25252525. What's different this time when we go to write it out as a sequence? It's 0.25 plus, you need a 0 for each digit, 25, plus, now you need a 0 for all how many? 4. All right? Since it's 2 digits repeating, you need 2 more zeros each time. What if it was 0.123123? Yep, you'd have 0.123 plus 0.000123 plus 0.60123, and so on. Can I get a U1? 0.25. R is no longer 0.1. It's 0.01. Do you understand how to find that? This divided by this divided by this, and so on. Or if it's 2 digits repeating, it's 0.01. If it's 3 digits repeating, R is 0.001. If 8 digits were repeating, you would need 0.7 zeros and a 1. Okay? So, is it geo? Infinite? Is R smaller than 1? So we can do sum equals first term over 1 minus 0.01. If you want to skip this step and just write 0.99, go for it. To change this to a fraction, a valid fraction, get rid of the decimals. As long as they're equal, you move them the same number of times. And we have 25/99ths, which can't be reduced. The top's divisible by 5. The bottom's divisible by 3. They don't have any common factors other than 1. So it's 25/99ths. Plug it in. Do 25 divided by 99. If it doesn't say 0.25, 0.25, 25, 25, 25, it does. We're good. I don't have to make any claims like, I'll jump out the window. Okay, so we're good? So on your green worksheet, number 1, if you look at that one, it's asking you to do 0.39393939. It's very similar to the blue one that I just did.